Hi, I'm Brian Myers, Senior Project Manager for Dayton Audio. Today, I'm going to instruct you on the symmetry test using the Dayton Audio DATS Loudspeaker Analyzer, or DATS LA. To begin, we need to have the unit calibrated and a full parameter set. There are other videos that we have to learn how to calibrate and do teal small parameters. However, I'm going to quickly run through my calibrated DATS LA and run teal small parameters. Bear with me. Measure free air parameters. Here, a low-level sweep. We're doing a small signal. And using delta mass method, we need to enter the diameter, which I know is 105, and the added mass method, which is my favorite, which is 44.2 grams. Measure it previously, and it says measure VAS. It prompts me to make sure the mass is added to the cone, so I firmly attach it. I say OK. You hear another small level sweep, and now you have your full parameter list on the right-hand side. Once we have that, we can move on to the symmetry test. We go to symmetry test mode, and on the left-hand side, you'll see you can enter the maximum DC voltage. And here I have 15. I'm going to up this. This driver's pretty stout. I'm going to up it to 20 volts DC. Now be careful if you have a little 3-inch driver, that has very little X max. You don't want to put 20 volt into it. And then all you have to do is push test. And the reason why, it says in the upper left-hand corner of the screen, you can see where sweeps each way is 9. So what it's doing 9 negative and 9 positive, and then 1 in the middle where X equals 0. And you can see when the sweep does a 9 negative, the yellow light will appear. When it goes positive, the red light will appear. It takes some time. When it's under high DC voltage, before the next sweep, we allow the voice coil to cool. So we wait. It's saying we're doing sweep 4 of 19 in progress, and it's saying cool down delay for unit under test. And if you noticed on the right-hand side, which each sweep, you're going to see the parameters change. And that's because it's DC biasing the driver, running a small signal sweep on top of that DC bias, and plotting all the parameters. And we're at 6 of 19. And if you look down below, you'll see notes. It tells you what sweeps it's on, the level of the sweeps, and the DC offset. You can see right now it's at negative 11.11 volts. Now it's negative 8.89. And it's almost halfway done. And we're just allowing time for the voice coil to cool, which is important. If the voice coil is warm, RE is going to increase and your parameters are going to be changed. We're on 11 from 19. You see as it gets close to 0 or 10, right around 10, it don't need as much time because the DC biasing, you can look at the driver and see how much it's DC biasing by how much the driver is moving in or out. When it moves hard in or hard out, then we have more time for let it cool. It's a function of the DC voltage, as the cooling time is a function of the DC voltage. 16, we're almost done here. Now, what this is going to provide us with is hopefully a nice symmetry graph. This allows you, as a speaker designer, to see voice coil offset. Okay, and we have one more sweep. We allow right at 30 seconds on the strongest. You can go up to 22 volt. I went to 20 on this driver. And that will be it. So now you see the BL symmetry. What I'm going to do is I'm going to zoom in a little bit. I'm going to take the bottom, and go to 3. Take the top and go to 7 and increase to 15 on the right to left x-axis. Now you can see on the graph the BL curve. If you notice on the right-hand side, you have your parameters of x equals 0, which is your center 1, which is actually memory 10. And I'll show you that in a minute. But if you look over here in the x max at the bottom of your parameters, at 70% BL, It's 8.62 in and 10.3 out. So it's a little bit asymmetric, as you can see in the graphs. Typically for subwoofer type drivers, 70% BL is your limit before distortion ensues. For mid ranges and small just woofers, it would be 82%. And what you can do on the right hand side, you can double click and you can get the 82% numbers or the 70% numbers. So, but with this being a small sub, we'll use the 70% numbers. Now, what I'd like to show you is you can always go back to impedance analyzer. And impedance analyzer mode, now you'll see this nice, symmetric, beautiful curves. And you can see, if you see something wrong and something out of place, you need to probably redo your driver because it should look a lot like what's pictured here on the screen. So that tells me that everything was working properly. And you can see here on the impedance menu that every sweep was saved to a memory. And you can look at each one individually. And if you see a nice uniform, beautiful curve, that is, it looks like everything's looking okay here. If you see something out of line, again, you might want to redo it, make sure the driver's secure, and but this looks good to go. So we go back to symmetry and symmetry test mode, and you can see the BL curve. This is asymmetric driver, and what I mean is it's not the same going in as going out. So you're only as strong as your weakest link. So if you have Xmax in as 8.62 and Xmax out is 10.3, you're only good as 8.62. You're only as good as your weakest link. So this is a driver that could be improved. The other thing I want to show you is you can actually look at not only BL, but KMS symmetry. That looks really good. It's really symmetric. It's hard to get. KMS symmetry is a little harder to get if it's off. It has to do with your spider and your surround, more of the suspension. And then you have LE, you have FS. Now, again, this is cone excursion down here, and it's the in, how many millimeters, and the out, how many millimeters. But you can do everything from all your parameters, DC, voltage, but BL is usually the most important, and KMS is also important in driver design. That's it. It's a great, simple to use, great tool for a speaker designer or the speaker enthusiast. I hope that helps, and see you in the next video.